Imagine you are floating at the edge of our solar system. Behind you, 4.5 billion kilometers away, the sun is just a bright dot. Smaller than a star seen with the naked eye from Earth, so faint it warms nothing, illuminates nothing, protects nothing. And before you, there is a planet? Blue. Perfectly blue. The color of a deep ocean, the color of a cloudless sky, the color of something that should be beautiful. But nothing on this planet is beautiful. Not up close. Winds of 2,100 kilometers per hour tear through the atmosphere in every direction at once. Surface temperatures plunge to below -200 degrees Celsius. Inside, the pressure is so absurd, it transforms gas into states of matter that don't exist in any lab on Earth. This planet has a storm larger than Earth that lasted for decades, then simply vanished. No warning, no explanation. Welcome to Neptune, the solar system's coldest nightmare. A deceptive beauty. From afar, Neptune seems peaceful. When Voyager 2, the only spacecraft to ever visit Neptune, sent back the first close-up images in 1989, scientists were speechless. The planet glowed with a deep, vivid blue, more saturated than Uranus, deeper than anything they expected. It was like looking at a sapphire the size of 4 Earths. White, wispy clouds swept across its atmosphere. There was a great dark spot, a storm so vast it seemed almost elegant, almost serene, floating on the planet's face like a giant pupil. For a moment, it seemed we had found something majestic. Then the data started coming in. Voyager's instruments measured the wind speeds. Computers processed the numbers. And the scientists at NASA's JPL in Pasadena had to double-check their calculations because what they were seeing made no sense. 2,100 kilometers per hour, the fastest winds of any planet in the solar system. Faster than Earth's strongest hurricanes by a factor of 20. So fast, that sound would take hours to travel the distance the wind covers in minutes. And here's what truly doesn't make sense. Neptune receives 900 times less solar energy than Earth. It exists in perpetual darkness, perpetual cold at a distance from the sun that makes solar heating practically irrelevant. So where do these winds come from? No one knows for sure. And that's just the beginning. A cold beyond comprehension. Let's put Neptune's temperature into real perspective. The coldest place ever recorded on Earth was in Antarctica, -89 degrees Celsius. People working at these research stations wear multiple layers of specialized gear, stay inside heated structures, and treat exposure to the outside air as a medical emergency. Neptune's upper cloud layer sits at -200 degrees Celsius. At the top of the atmosphere, in the thermosphere, temperatures inexplicably rise to hundreds of degrees above zero, a phenomenon scientists call the heating problem, with no definitive explanation. But this heat exists in a region so thin, so rarefied, that it warms nothing, protects nothing. It's heat without comfort, energy without purpose. But dive deeper into the atmosphere, and the story changes completely. As you descend into Neptune's lower layers, the pressure begins to rise in ways the human body was never designed to withstand. With every kilometer of depth, the weight of the atmosphere above doubles, triples, multiplies. And the cold remains. It doesn't relent. It doesn't yield. There is no finish line on Neptune where the environment becomes habitable. It's cold and violent at the top, cold and crushing in the middle, and at the bottom. But here's the problem. Neptune has no bottom. Not in the way you imagine. No surface to stand on. This is something most people never consider about gas giants. There is no place to land on Neptune. No solid surface awaits you below. No rock, no ground, no place where you could theoretically stand and look around. What exists is a gradual, or a brutal transition from gas to liquid to something that doesn't even have a proper name in everyday language. A state of matter called supercritical fluid, where the distinction between gas and liquid ceases to exist. Imagine diving into the ocean. Now imagine that as you go deeper, The water doesn't just get colder and darker, it gets denser, stranger, more unlike anything you recognize as matter. Eventually, you'd pass through a layer scientists call the ice ocean. Not ice as you know it, but water, ammonia, and methane compressed to such extreme pressures that they behave like a thick, superheated liquid at the same time. It's ice that's hot. It's liquid that's solid. It's matter in a state that doesn't exist anywhere naturally on Earth. And it keeps getting stranger. At Neptune's core, where the pressure reaches millions of times Earth's atmospheric pressure, scientists believe something happens to carbon, something that sounds like science fiction, but is verifiable physics. And this is where things change completely. Diamonds in the sky inside Neptune? It might be raining diamonds. Not metaphorically, literally. Real solid diamonds falling through the planet's inner atmosphere like raindrops on Earth. Here's how it works. Methane, a simple, common gas, is abundant in Neptune's atmosphere. When this methane is subjected to the planet's extreme pressures and temperatures, the molecules break apart. Carbon atoms are released, and under enough pressure, pure carbon crystallizes. It becomes diamond. These diamond crystals form in the upper layers of the mantle and sink, literally fall through the dense fluid layers toward the core. Researchers at Stanford University and the SLAC National Accelerator Laboratory simulated these conditions in 2017, firing high-powered lasers at plastic samples to replicate Neptune's internal pressures. The result? Nanodiamonds formed in nanoseconds. Neptune's interior may have a constant rain of diamonds falling toward a rocky core surrounded by a liquid diamond ocean. The most hostile planet in the solar system may be literally lined with diamonds, and they are completely inaccessible, completely useless to us, shielded by layers of pressure and temperature that would destroy any machine we've ever built before it got close. The universe doesn't just guard its treasures, it places them exactly where no human will ever reach them. But it gets much worse. Winds of destruction. Let's return to the winds, because you need to understand what 2,100 kilometers per hour really means. The most intense hurricane ever recorded on Earth, Hurricane Patricia in 2015, reached winds of 345 kilometers per hour. It destroyed entire communities, uprooted trees, lifted vehicles, killed people. Neptune's winds are 6 times faster. But speed is only part of the story. The other part is what these winds carry. Neptune's atmosphere is mostly hydrogen and helium, with about 1% to 2% methane. It's this methane that absorbs red light and reflects blue, giving the planet its signature color. But mixed into this gas soup are ammonia, water ice, sulfur compounds, and ice particles whipped from one altitude to another at speeds that make any terrestrial turbulence seem like a gentle breeze. These particles act like sandpaper, abrasive, constant, relentless. If you were somehow suspended in Neptune's atmosphere, protected from the pressure, the temperature, the winds wouldn't just push you, they would flay you, strip layers from any material you were wearing, not in hours, in minutes, in seconds. And here's the part scientists still can't fully explain. These winds don't blow in one direction. They blow in opposite directions simultaneously. There are wind bands at the equator moving one way and bands at the poles moving another, creating shear zones where the two systems collide. It's chaos at supersonic speed. On Jupiter, the solar system's largest planet, and with 300 times Earth's mass, winds reach 530 kilometers per hour. Neptune, a much smaller planet, has winds 4 times faster. Again, no one knows why, but that's not even the worst. The vanishing storms. In 1989, when Voyager 2 flew by Neptune, it photographed the Great Dark Spot. It was an Earth-sized storm, an anticyclonic vortex spinning in Neptune's atmosphere, stable enough to be photographed and tracked throughout the probe's flyby. Scientists were immediately excited. They compared it to Jupiter's Great Red Spot, a storm that has existed for at least 350 years and persists to this day. They assumed Neptune's great dark spot would be similar, long-lasting, stable, a permanent landmark on the planet. 5 years later, the Hubble Space Telescope pointed at Neptune to take follow-up images. The great dark spot had vanished, not weakened, not migrated, gone, as if it had never existed. And here's the truly unsettling part. Since then, new dark spots have appeared and disappeared on Neptune in completely unpredictable ways. In 2018, Hubble detected a new large dark spot. In 2020, it observed the spot behaving in a way no model predicted. Instead of migrating toward the equator and dissipating, as simulations suggested, it turned and began moving toward the North Pole. The planet simply doesn't follow the rules. Neptune's storms form and vanish on timescales of years, fast for a planetary phenomenon. Jupiter's storms last centuries. The difference is so dramatic that scientists are still trying to understand what makes Neptune's atmosphere so fundamentally unstable. A planet in the dark, in the cold, billions of kilometers from anything that could warm it. And yet it seethes from within with energy it shouldn't have. And this is where everything becomes existentially unsettling. A planet out of place. Neptune shouldn't be where it is. This isn't a hypothesis. It's the current consensus of planetary science. According to the NICE model, the most accepted theory of the solar system's formation, Neptune and Uranus formed much closer to the Sun than they are today. The outer region of the solar system, where Neptune orbits now, was too dense, too cold, too sparse in material to have allowed the formation of an ice giant of that size, so Neptune migrated. Pushed by gravitational interactions with Jupiter and Saturn, it moved outward, and as it moved, it devastated the young solar system. It captured Triton, its largest moon, likely a Kuiper Belt object that was snared by Neptune's gravity and doomed to a retrograde orbit. An orbit that goes against the planet's rotation, a unique feature among the solar system's major moons. Triton is slowly spiraling inward toward Neptune. In about 3.6 billion years, it will cross the Roche limit, the point where Neptune's tidal forces will be strong enough to tear the moon apart. Neptune will eventually have a ring system as dense as Saturn's, built from the remains of its own satellite. But before that, Neptune's migration likely swept hundreds of Kuiper Belt objects into the inner solar system, causing an event called the Late Heavy Bombardment, a period of catastrophic impacts that struck Earth, the Moon, Mars, and other planets about 4 billion years ago. Earth was bombarded by asteroids and comets because of Neptune. Life on Earth nearly didn't exist because of Neptune, and Neptune remains there, in the dark, cold and indifferent, unaware and uncaring of what it did. The isolation. There is something profoundly unsettling about Neptune that goes beyond all the physics. It's the isolation. Since Voyager 2 flew by in August 1989, no other probe has visited Neptune. No mission has been sent. For 35 years, a whole human generation, the solar system's farthest planet, has remained silent, unobserved up close, ununderstood up close, doing what it has done since it formed 4.5 billion years ago. Winds tearing through an atmosphere no living being has ever seen from within. Diamonds falling into an ocean no instrument has ever reached. Storms appearing and vanishing without witnesses. A doomed moon slowly spiraling toward its destruction. So all of this happening now, at this very moment, while you sit here, warm, breathing, alive. 4.5 billion kilometers away, Neptune endures, indifferent, permanent, incomprehensible, and it is our planet, part of our solar system, the closest of our distant neighbors in cosmic terms. If Neptune is like this, if something so close to us, in the same star system, in the same galactic neighborhood, is so hostile, so strange, so beyond our ability to visit or fully understand, what exists beyond? The Milky Way has 200 billion stars. Most of them have planets. And if the planets around the stars nearest to us are as alien as Neptune, what inhabits the orbits of the farthest stars? What lies in the galaxies beyond ours? What exists in the dark between galaxies? The honest answer is that we don't know. The even more honest answer is that we may never know. Neptune teaches us something we don't want to accept. The universe owes us no explanations. It was not built to be visited. It was not designed to be understood. And it will continue doing what it has always done. Winds at 2,100 kilometers per hour, diamond rain, storms born and dying without witnesses, long after the last memory of anything human has vanished. Blue, perfect, absolutely indifferent. Neptune isn't a nightmare because it's terrifying. It's a nightmare because it's eternal. And we are not.